We got some questions over here, just behind you, Ted.
Yeah, I've been reading about RAG with re-ranking that will bring the relevance document back to the context query. Have you experimented with that re-ranking process?
No, I haven't.
Okay.
I'll look into that.
Any other questions?
Has anyone heard about homomorphic encryption before this? Okay, so a few people have. Today, without homomorphic encryption, you are having to trust Sam Altman or even Dario. You might like Dario. You look at Dario, you think, he's like sort of the punch the monkey. You feel like he's that monkey. But in any case, you have to trust them. And when you want to use their AI services, you have to upload your context in clear text. Is there a way in which you can upload it securely? So they can still run AI on your content, but they never see the raw content, and you get back the correct answer. And we've cracked that within Kwaai. Question.
Is there code that we can see about? Yes.
There's a paper.
Yeah. So on the Kwaai GitHub, I think we have the code, and you can reach out to me. I'll update the GitHub if it's not in there already. RAG is retrieval augmented generation, meaning when I send data to LLM to infer, I don't want to send the entire document. I want to retrieve the parts of the document first. It's the retrieval step. What part of this textbook has the answer to the question I want? Most likely.
In user terms, if you were to ask ChatGPT, what's the capital of France? Okay, it'll know that because it has general knowledge. If you were to ask it, what's the eye color of my grandmother? It would not know that. And so you augment the LLM with a private data set. And that's what is called the context sometimes, that you upload to your favorite AI system. And then the LLM just does what's called the chat completion. So you first do a retrieval of your knowledge base of, give me the top 10 chunks of my knowledge base that could form the answer. And then the LLM just does the simple job of taking that data and structuring it into an answer. So you're not relying on its general knowledge because it didn't know who your grandmother was. Okay, so I hope that answers the question about what's RAG. We've got a question over here.
Yeah, so in regards to RAG and data, there's a lot of experts who they have expertise and knowledge, so you could build them their digital twin. How can they trademark that?
Exactly. I mean, some of the speakers were alluding to that about individuals having their own, creating an economy of knowledge, rather than the tacit assumption that the half a dozen oligarchs who control AI have, is that all the data they can see is theirs to grab. Instead, we believe you own your own data and you get to choose how to monetize it. But you might also want to choose your private collection of experts that you want to draw upon. And so what Ben was talking about earlier on was about a distributed graph knowledge base, where it's not just your knowledge, but you get to pick the 200-300 experts, and when you do the query, it's drawing from their knowledge. And not necessarily free, that might be a paid service, but it allows each of us to construct our own expert council, for instance, from a distributed knowledge base. So I'm talking through your carry on. Great. Okay.
This is more of a question for the presenter. The methodology in use for homomorphic encryption, you're preserving the properties of the dot product between the vectors, if I'm understanding correctly?
Yeah, so we examined L2, cosine similarity, and dot product. But
Gotcha.
Yeah.
So do you have any concerns with data leakage by virtue of the fact that you're preserving relationships between data that is supposed to be confidential? Many encryption algorithms specifically make self-similar information not appear self-similar to prevent this sort of leakage.
That's a really good point. We definitely need to, I think, look back into that more. So we took the algorithm and found the best known attack method that's in the literature for each algorithm and applied that. But I know that it's kind of hard to do that for maybe new algorithms that no one has come up with
I was wondering if you had seen the result from Cornell, I think earlier this year, about translation between vector spaces. because they found some pretty interesting relationships on like latent spaces that you can construct between vector spaces with enough samples. So if this is really deep into the research. If you've built like an effectively kind of pseudo-random transform, you might actually be able to deconstruct some interesting data.
We did develop a solution to that attack, so we don't actually return to you the vectors that you're querying. We only return the index of the vector, and so you're really operating under two cryptographic regimes. One is the scrambling of the vector, and then when a third party, when Eve, the untrusted host, is hosting your vector database, the vectors are in a random order, and that randomization is a key, is in effect a cryptographic key. And so when you say, give me the top K results, it's not actually giving you the results, it's giving you the index of the results and the similarity score. So it's very difficult to get to figure out what the actual vector was.
Okay, so one last question. I saw somebody.
Just to follow up on clarifying the use of this. So a use case might be, say, a developer that has developed a library or a set of libraries and say coding standards over 20 years, and they want to take advantage, they want to hire a general purpose AI, but they don't want to provide their 20 years of research and development to that AI so they can be joined into a general model. And they're willing to pay for that, but they don't want that. In fact, I'm that guy, right? I've been in that situation. I'm like, I'm going to upload this and I'm going to give away my competitive advantage by uploading it. And so therefore I don't want to use it.
That's exactly kind of use case.
That's exactly the use case, yeah.
Awesome. Thank you, Solomon.
Solomon, thank you so much.
Thank you.
Thank you.